Welcome to aminacademy.com. In mathematical economics, let us discuss about rules of differentiation. Here in economics, the differentiation is very useful tool for finding different various parameters for economics. In that, we'll discuss about rules of differentiation. The product rule. In calculus, the product rule or Leibniz rule is a formula used to find a derivative of a product of two or more functions. Here the product rule is d by dx of f of x, g of x. Here f of x and g of x is a two function, the product, which is equal f of x into g dash of x, that is first function multiplied the derivative of the second plus second function into derivative of the first function. Now let us do an example to understand this concept. Look at here. Here, take one example. Y equal 4x squared into 3x plus 5 whole power 4. Here we have to find y dash, derivative of y. Let u, the first function, is 4x squared. Then v, the second function, is 3x plus 5 power 4. Here, derivative of the first function, that is u dash equal, that's 2 comes front, the power, that is 4 into 2 is 8, x, 2 minus 1 is 1, that is 8x. Here v dash equal 4 into 3x plus 5, reduce the power as 1, then 4 minus 1 is 3, into the derivative of inside function. 3x derivative is 3. Therefore, now we can use it y dash equal, by product rule, u v dash plus v u dash, which is equal, u is 4x squared into v dash. V dash is equal 4 into 3x plus 5 power 3 into 3 plus v is this 3x plus 5 power 4 into u dash is 8x. Now we'll simplify these things. Look at here. 4x squared into 4 into 3, that is 4 4 are 16, 16 into 3 is 48 x squared into 3x plus 5 cube. Look at here. 4 into 4 is 16 into 3, that is out, that is 48 into x squared, and this one plus 8x, 3x plus 5. Further, in this combination, that is 48x squared, 8x, then 8x is common factor. Then look at here, 8x means 6x, since x into x is x squared, 6 into 8 is 48, and use the square bracket, 6x. Also, this 8x will come, and the second function, that is a 3x plus 5 whole cube, 3x plus 5 whole 4. The common is 3x plus 5 whole cube. Then here 48x square, that 8x out, so 6x, and this completely out because 3x plus 5 whole cube is take out. Then plus here for 8x out, this completely out, that here 3x plus 5 whole cube, but here 4 is there, so one more 3x plus 5. So we have 8x 3x plus 5 the cube, and 6x plus 3x is 9x plus 5. So we can write in order 8x into 9x plus 5 into 3x plus 5 the cube is differentiation of the products. Next, look at here. Next is a quotient rule. The quotient rule in calculus is method to use to find the derivative of any function given in the form of quotient obtained from the result of the division of two differential functions. Look at here. This quotient rule is f dash of x equal to u v u dash minus u v dash over v square. Means the denominator is v square, the second function square, numerator is v second function into derivative of first minus first function into derivative of the second. Suppose we use one example to understand this concept. Look at here. So y equal 10x power 5 minus 3x square over 2x. Here, the 2x plus 3 the square. Here, how to differentiate this? This is a having numerator and denominator. Let u equal 10x power 5 minus 3x square. Then v equal 2x plus 3 the square. Now u dash, the derivative of the numerator, that is here 10x power 5 equal 50x power 4, because the power is reduced by 1, that is 5 minus 1 is 4. Then 5 into 10 is 50. Here 3 into 2, this 3 into 2 is 6 as well. 2 minus 1 is 1, not necessary to put. V dash is here the power come first in front, 2 into 2x plus 3, then 2 minus 1 is 1, you can put or not, no problem. This is V dash. Now V dash, for the simplification, V dash equal 4x plus 6. Now apply the rule, quotient rule, y dash equal v square. Here u dash is not u dash is this is okay. Then v dash, look at it, v dash is something, is extra things are there. Look at here, v dash equal 2 comes front, 2x plus 3, and integral differentiation of this 2x is 2. Into 2 comes, that is, so totally here 8x, this is 8x plus 3 into 2 is 6. Take note here, if the function is in power, so first reduce the power, that is 2 into 2x plus 3 power 1 into inner differentiation. Inner differentiation is 2x differentiation is 2, that is multiply. Take care. Here, then v dash into v u dash minus u v dash. Then look at here, v is 2x plus 3 whole square and u dash is 50x power 4 minus 6x. minus u is 10x power 5 minus 3x square, and v days is 8x plus 6, 8x plus 6, then it is all divided by v square. V is already, we have this 2x plus 3 whole square, power 2 is 2x plus 3 whole power 4, 2x plus 3 whole power 4. Now this, that means we have to expand this and multiply with this vectors, and this multiply by chain rule, then divided by this one, simplification. This enough to understand the concept. This you know, to opening the bracket and simplifying. Next question, next topic. Next one, generalized power rule. Here the generalized power rule is a chain rule that is used to find the derivative of a function that is raised to the nth power. That already we have done in this. Look at here, the general power rule is y, suppose y equal to f of x power n function, y dash is nothing but n into x, f of x reduced to 1, that is n minus 1 into differential of inside f dash of x. For example, if y equal 7x squared plus 3 whole power 5. What is the derivative of y dash? That is y dash. Y's derivative is y dash. In that, first the function f of x is here 7x squared plus 3 power 5. So first the 5 come front, 7x squared plus 3, then reducing the power 1 by 4. That is 5 minus 1 is 4. Then inner derivatives. Inside 7x squared is there, 7x squared plus 3, derivative of 7x squared is 14x. That is multiplied. This is the rule. So multiply 14 into 5 is 9, 70 into 7x squared plus 3 power 4. Next one, the chain rule. The chain rule is also known as the outside inside rule or composite function rule or function of function rule. It's used only to find the derivatives of the composite functions. Look at here, chain rule. If y equal to f of u, where u equal to g of x, then dy by dx equal dy by du, first derivative, and multiply with the derivative of this one, that is du by dx. We'll use one chain rule. An example. Look at here. Y equal 3x power 5 minus 8 whole power 5 whole power 6. Then how to use chain rule to find this one? So let inner function u is 3x power 5 minus 8. That is, then outer function y equal u power 6 because this we let inside bracket is u, then y equal this one. Therefore, from here we can find u dash. What is u dash here? Is 5 into 3 is 15 x power 4 minus 8. Differentiation is 0. Here y dash is y equal to u power 6. Then dy by dx, therefore you can say, then from this, look at here, before that, you can find dy over du. Here, instead of u dash, we can write this as differentiation of u with respect to x. du by du is 6 u power 5. Now, therefore, we need dy by dx equal du by dx into dy by du. Look at here. Here, this is du is up and down. Then it may cut, so you can get it dy by dx. This is called a chain rule. But you cannot cut here du and du here. Then we have to substitute. Du by dx is 15 x power 4 into dy by du is 6 u power 5. U is already 6 into 3 x power 5 minus 8 over 5. So we have 6 into 15 is 90 x power 4 into 3 x power 5 minus 8 over 5. So this is the result for this. Look at here. Normally you can use it. This 6 into that is 15, 90. Okay. This is y dash you can write. Next one. Next, so far we discussed about some rules of differentiation which is useful in economics. We have done. Please subscribe our YouTube channel.